Hi, and welcome to the first of our many function videos. This video we would consider a polynomial function video, poly meaning many, nomial meaning unit. So we're talking about many units. This one specifically is quadratic because that variable is to the power of 2. So the highest variable in the function has a 2. After this, we'll talk about cubic, where it'll be x to the power of 3. But all of the functions that we'll look at, the highest exponent will be a 2. And so what a function is basically a box. Numbers go in and numbers come out. So numbers go into the x spot, they churn inside of the box, and they get spit out as y's. And so you get this pairing of numbers. So for example, with this function here, I could put in a 0. And if I put 0 into this space, it's 0 squared, 0 times 0 is 0, and I subtract 3 from it, the answer, what gets spit out, is minus 3. Now what I have here is I have a pairing of numbers, and what we can call that is actually a point. So this point is 0, comma 3, and we put that inside brackets to show that it is a point. The x value is always first, and the y value is always second. This can be plotted, and it's plotted on a coordinate plane. So the coordinate plane is divided up into quadrants, and it's cut through by the x-axis and cut through by the y-axis. All of these sort of vocabulary terms, if you find that they're new to you, you might want to make a list of them because they're going to be useful over the next little while. So we've got our two axes, and we also have the quadrants. So let's just label this. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So this is sort of how we look at the coordinate plane. We look counterclockwise. And let's plot this point. So we need to go to the place where x is 0. And this is the x-axis. We can see we see a 5. So we're thinking that each one of these lines is worth 1. And x is 0 right here in the center. So that's 5, 4, 3, 2, 1. And y is negative 3. Well, let's go down. 1, 2, 3. And when we plot that point, that is the position of 0, comma, negative 3. Let's go back to the beginning. Let's put in a number 1. Let's throw 1 into our function. So 1 goes in this place. 1 squared, 1 times 1 is 1. Minus 3 becomes out minus 2. So let's plot this point with a 1 and a minus 2. So we'll go here to a plus 1 for x and a minus 2 for y. Let's try, something on the other side. Let's put in a minus 1. Minus 1 times minus 1. If you remember back to math in the real world, 2 minuses, when you multiply them, they become positive. So that's a positive 1 minus 3 becomes, again, minus 2. So we'll see a minus 1 for the x and a minus 2 for the y. Let's try these guys. So we'll put 2 in. 2 squared becomes 4. 4 minus 3 will be a plus 1. So when x is 2, y is plus 1. And when we put minus 2 in, minus 2 squared becomes a positive 4, minus 3 becomes a 1 as well. Last one. We don't always do it like this. Basically, this is what we're going to use our graphing tools for online, because this gets tedious. 3. 3 squared is 9. Minus 3 is 6. So when x is 3, y is 6. And when x is minus 3, y will also be 6. So what we have here is we have these dots, and we can approximate the space in between the dots, and we can take a guess that this function kind of continues up and on, like in that direction. So we put those little arrowheads to show that it continues upwards like that. Now that we have our function plotted, let's take a look at some of the characteristics of the function. So the vertex is either the highest or the lowest point. This itself, being quadratic, is called a parabola. It's not really a parabola. Some people pronounce it like that, but it's parabola. So the vertex is either the highest or the lowest point on the parabola. In which case here, we're going to find it here at minus or 0, comma, minus 3. So we always show our points as x and y values. So it's when x is 0 and y is minus 3. That's our vertex. The axis of symmetry comes from the x value of the vertex. So an axis of symmetry is like a mirror that, you know, the function itself is reflected. So if we look here and we look in the mirror, we can see how this would be like a reflection of that one. So the axis of symmetry is when x equals 0. Notice that this is the x value of the vertex. The x-intercepts, we're going to have to take an estimate on these. This is where it's crossing the x-axis, where y is 0. And so maybe we'll call that 1.5, comma, 0. And over here, we'll call that negative 1.5 for x, comma, 0. Y-intercepts, where does this graph cross the y-axis? And it happens to be crossing, this case, at the vertex. So we would see it at 0, comma, 3. The domain. Domain is all the x values that are contained within this function. So what values of x could we put into the function and actually get a real answer out? And basically we could put any possible number in, all the way like to a positive 1,000,000 and all the way down to negative 1,000,000 and 0. Every possible number for x works. So we would say x is in the set of all real numbers. So capital R, this guy looks a little bit like a euro sign, but this symbol means as a member of the set of, x is a member of the set of R, or real numbers. The range is the y values. So what y values can be outputted from this function? Now, I'll bet $50 that we can't get minus 5 out. What number would you have to put in to get minus 5 out? Try it, please. But don't try too hard because it's impossible. It's outside the range of the function. So the range of the function is y has to be greater than or equal to minus 3. Y can be any of these numbers because we see that this is an increasing function, that it's opening upwards. As x increases, as x goes up, y goes up. And so y has to be greater than or equal to minus 3, and till forever. So it could be plus 1,000,000, that's fine. But it can't never be negative 1,000,000. It can't even be negative 5. So the end behavior, when we're looking at this, we're looking from left to right. So I like to think about it as like sweeping. I sweep from left to right. When do I meet the function from left to right? When do I leave the function? So I'm going to meet the function here in quadrant 2. The first time I see the function is in quadrant 2. And then, yes, it goes through 3 and 4, and then I'm going to leave it in quadrant 1. So we could say that the end behavior of this function goes from quadrant 2 to quadrant 1. Whew, that's lots. So let's look at another example where the graph's already drawn, which is normally what's going to happen. We're going to use the graphing tools to graph our function and give us all the possible outputs. But let's pull off those values. So the vertex, again, is the highest or lowest point on the parabola. And in this case here, now just looking at our axes, being really careful about this, because this is a 10. So my guess is actually this is going to be 2, 4, 6, 8, 10. Be really careful about the units on your axes. So in this case, our vertex here, the x value is 4, and the y value is 2, 4, 6. So we've got x and y. The axis of symmetry is going to be the x value of the vertex. So x will be equal to 4. Any x-intercepts we want to show as points. So we see it crossing here at when x is 10 and y is 0. And we see it crossing over here also when x is 2 and y is 0. Remember that these are hopping. Oh, -2. Good one. -2. The y-intercept, where does this graph cross the y-axis? We can see it crossing here at 0 for x and a +2 for y. The domain, again, for a quadratic function, if we're looking at, all the possible x values, we would say x is in the set of all real numbers. And yes, it's always going to be like this, no matter what quadratic function you're going to look at. The range, however, we really are going to keep looking at this vertex. So we want to refer back to the vertex value, so 6. And then looking at the graph, is y bigger than or equal to 6 or less than or equal to 6? And we can see that it starts at 6 and y is everything that's below that. So y has to be less than or equal to 6. In terms of end behavior, if we swipe from left to right, thinking that our quadrants, and oftentimes they're using Roman numerals for these quadrants. So as we swipe from left to right, we're going to meet the function here in quadrant 3, and we're going to leave it in quadrant 4. And for this guy, as x gets bigger, as x increases, the value for y decreases. So I would call this a decreasing function. As x gets bigger, so as we go from 10 to 20, we would see y get smaller, or more negative. Again, so this is sort of a parabola that's opening downwards. You've also got your other form where the parabolas are opening upwards. These are our two forms for our quadratic functions.